Alright guys, so I'm recording this video for you tonight because I can't be at my workbench tomorrow. I gotta be out on the road. Unfortunately, something can't wait. Sorry. But might work out for the best because this second part is a little bit more difficult. So you might want to pause videos and stuff like that, rewind it and whatever. But let's start out with this simple little thing. Now, if we were in class, I would have given you pieces like this. So the question is, can I make a triangle out of any three of these, like no matter what I pick, or is there like some sort of rule maybe that makes them possible or not? You know what I mean? So I would like throw these pieces at you, and I tell you, hey, try and make some triangles. By the way, this is all measured in inches. Okay, the only way to measure things. So let's try one. How about the quintessential right triangle, the 3, 4, 5. Yeah, that's a triangle, right? 3, 4, 5. That works out. What if I replace the 3 with a 2? I can just decrease that angle, and yeah, I still have myself a triangle, right? It's not perfect because obviously, these aren't really infinitesimally small or like one-dimensional, but it's still obviously a triangle. What if I replace the 4 with a 3? That certainly is not a triangle, right? I mean, like, if I can fake it, right? But clearly, I'm pushing it off from the edge there to make that work, right? They're not perfectly lined up which way they should be. So, and you might notice also that 2 plus 3 is 5. So how could I possibly, you know, make a triangle out of that? Here, let's try it again. So 3, 4, 5 works, right? So 3, 4, and 5. These two, okay, that works. 3, a 4 and a 2 seem to work, right? So 4 and 2 and 5 seem to work. But 3 and 2 and 5 certainly don't work. And you might notice also that 2 plus 3 is equal to 5. So maybe that's the problem. If I replace the 3 with a... Oh, geez, I froze on myself here. If I replace the 2 with a 2, then I have something even worse, right? Like, there's no way that that's going to make a triangle no matter what. But what if I replace the 5 now with something like the 3? Now I can make a triangle, right? So I have 2, 2, and 3 here. That works. If I replace the 3 with a 4, I get the same problems as I did before. And again, you'll notice that 2 plus 2 is equal to 4. Okay, what happens if I replace the 2 with the 3? Oh, I've got myself a triangle again, okay? So hopefully you've made the connection here that there's something to do with these two numbers in relation to the biggest number. And if you are thinking that, then you're on the right track, right? So check this out. 2 plus 3 is 5, right? And 5 is more than 4. Makes a triangle. Okay, 3 and 4 add up to 7, which is bigger than 5. So it makes a triangle. Okay. 2 plus 4 is equal to 6, which is bigger than 5. So it makes a triangle. Okay, so that's the rule. These two smaller pieces, whether it be 2 and 4 or 3 and 4, whatever, the two smaller pieces have to be bigger than the other number when you add them up. 2 plus 4 is 6, which is bigger than 5, so it makes a triangle. Okay? As we saw, it doesn't work out if they're equal. So that just makes another line. That's not a triangle. So that's what it's all about. Let's formalize it in some mathematical lingo. Alrighty? So this is called the triangle inequality theorem. And this is essentially what we just talked about. So here it's pretty obvious that AC is the biggest side, right? And so that's kind of what we're comparing, really, when I want to see if it's possible triangle. Are the two smaller sides bigger than the biggest side when I add them up, right? And that's clearly the case here. In general, though, if you don't know what the largest side is, well, then you have to make sure, and you can do that by this process, saying that any two sides have to be bigger than the other side. And that's obviously true too, as it was true in our example here. Let's just quickly look at it because it's nice to have a model, right? So you'll notice that 3 plus 4 is greater than 5, but you'll also notice that 5 plus 3 is also greater than 4, right? 5 plus 4 is also greater than 3. So it works all the way around and across, and every sort of combination you can get. That's the triangle inequality theorem. Inequality because of, well, the inequality. One's always greater. So here's the situation. We have to determine what are the possible values of x that would make this a triangle. And there are two cases here, okay? The first case is if my unknowns, so there's only, let's backtrack here real quick. There's two known sides, the 12 and the 8. The 12 and the 8. Now, either one of two things is true for a given triangle. Either 12 is the biggest, right? Because certainly not 8. 8's obviously not the biggest because 12 is bigger than 8. Or x is the biggest. Okay? Or x is the biggest. And if this is confusing for you for a moment, I might ask you to pause and read this small paragraph. Okay? So maybe 12 is the biggest. Or maybe the unknown is the biggest. Right? We don't know until we look. In either case, since it's variable, it could be any and all of these things because we're asking for all possible outcomes that would give us a triangle. So we have to do that, and we'll use mathematics to show that using algebra. Okay, so if 12 is the biggest, then it's going to go on the right-hand side, right? And the other two smaller pieces, x and 8, have to add up to be bigger than it. Okay? So that's not hard to do. I just have to pick the 8 and move to the other side. 12 minus 8 is, of course, 4. So x has to be bigger than 4 if it's going to be one of the smaller sides. But remember, it's possible that x is not the smaller side. X is actually the bigger side. So in that case, where would x be in this equation? If you said on the right, you're right. What if x is the bigger side and these two smaller pieces are the ones that have to add up to be bigger than x? Well, that means that x would have to be less than 20. Okay? And there is a way that I could write both of these together in a nice, pretty, eloquent little way. And that's by putting x in the middle, right? And saying that x has to be bigger than 4, but x has to be less than 20. So that's how we're going to do these sorts of things. If you're given a problem where you have two sides and an unknown side, you have to assume both cases, right? You have to assume that x maybe is one of the smaller sides, and you have to assume that maybe x is the biggest side, right? And put it over here, and then solve them independently and add them together. Okay, so in class, hopefully we got to both these examples. I think we did. Let's look at this one more example here, and I want you to really try it. Okay, you're not going to get better at something unless you try it on your own. All right, watching me is nice, but you're not going to learn anything just by watching me. you have to try to learn how to take your own steps. So try it on your own, and once you get stuck, then you can play the video. So two sides of the triangle are given. Describe the possible lengths of the third side. Well, there's two possibilities, right? The first possibility is that unknown side, x is my smaller side. So I'll have it x over here, and I'll have my other pieces. Now, how would I know that 10 is the biggest? Well, 10 is bigger than 4, right? So maybe this is the case. Maybe x is small. Or maybe the opposite's true, right? Maybe x is the bigger side, right? In which case it would have to be on the right-hand side. And these two would be the smaller pieces. Okay, so solving for this is easy. Subtract 4, right? Combine. Okay, so x has to be greater than 6, but x has to be less than 14. So this third side, if I have those two pieces, could be anything in between these numbers, right? Hopefully that went well for you. All right, let's just do one thought experiment here. Let's do 4 and 5. Okay, so what are the possible side lengths for the triangle if I have 4 and 5? Do it just like we just did. Okay, all right, 4 and 5, then work it out. So think about it. And it has to be somewhere like that. If it's like this, then that means that it's going to be equal, right? My piece would have to be like right up to it. That'd be a 1. So it has to be bigger than 1 for it to give me some sort of angle. It could even be like 1.1, something just a little bit. It'd be a really super small triangle, but it'd be a triangle. Okay, but what if, it's the bigger side, right? I have to make these two as obtuse as can be. Well, then this has to be just bigger than 4 plus 7. I'm sorry, 4 plus 5. That's supposed to be a 5. It's like upside down. Okay? 4 plus 5 is 9, so it has to be bigger than 9, like 9.1. And if you work out the math, right? If my unknown is the smallest, it's x plus 4 must be bigger than 5. Right, that's what we did there. It has to be just bigger than 5, right? So I have to make sure that that piece that is unknown here is like just bigger than 1, right? And that's exactly what we show. And the same is true. I need to be just bigger than 9 in order to make this a proper triangle. And that's exactly how it works out. Well, I should have said x has to be just less than 9. Otherwise, I'll just get like a straight line like that. Okay? All right, guys. Hope that worked out for you. Those are the notes. Please submit them. And take a look at the iExcel that's posted. We'll be working on that and some posted problems on Canvas that will be graded. So practice the iExcels and submit these notes. Hope that went well.